morning all of you. Today we will see the next point, that is applications of radioisotopes as tracers. Now there are totally 4 applications as concerned to your syllabus. Now today, day by day, applications of radioisotopes they will be increases as concerned to, in case of the that is nuclear chemistry, chemical investigations. First is a chemical investigation. In case of chemical investigation, the use of O18 isotope can be done. Now what happens in case of chemical investigation? Chemical investigation is nothing but esterification of the, you can say, that is ester formation. Then how the formation of ester can be takes place. Now in case of ester formation, what happens? One will be taken as acid, second will be alcohols. Both can be combined together and formation of ester can be takes place. And during here, water molecule can be eliminated. For the scientist, there was a dilemma how the water molecule can be eliminated. Now here there are 2 ways to eliminate the water molecules. If we have taken, that is here OH, one way will be OH from the alcohols and H from the acids. This will be one way to eliminate as concerned with the water molecules. The another one way here, that is the OH from the acids, this can be taken, CH from the alcohol, this can be taken, and totally formation of water molecule can be takes place. The scientist comes in the confusions how this water molecule can be eliminated in case of the ester formations, and they have taken, that is the use of radioisotopes, that is you can say O18 they have taken. Now totally the O which will be taken in case of the alcohol, it can be labeled as O18, and totally reaction can be carried out. That time it is found that the labeled isotope O18 it can be enters into the ester, and therefore totally what happens here, only H can be remains. Here H can be remains to combine as concerned to this acid OH, and therefore the bond breaking can be takes place. In case of the alcohols, what happens in case of the alcohols? In case of the alcohols, here carbon, again here oxygen, again here H, means the bond breaking can be occurs in case of, that is O and H can be takes place in the alcohols. Here what happens? Carbon OH, this bond can be broken down, and totally the combinations of OH from the acid, H from the alcohol, it can be used the formation of H2O molecules. And this idea can be obtained only by the use of labeled isotopes, you can say O18, and therefore esterification reaction it will be studied by taking of this isotope O18 is most important, because it can be used the specific activity of the O18, it will be goes along with the alcohols in case of the esters, and therefore only H from the alcohol and OH from the acid both combines together and formation of H2O molecule can be takes place. Now this is the idea as concerned to esterification reactions. Now next application can be taken here, that is structural determinations, that is the determination of PCl5 structures, that is phosphorus pentachlorides. And in case of PCl5 determination, here Cl36, this isotope can be useful. Now what happens in case of PCl5? Totally there are 5 Cl atoms. Either they are equivalent as concerned to the phosphorus or not. This was a question in case of, that is in front of the scientist. And how it can be solved? It can be solved by taking of, you can say, labeled isotope Cl36. Now how it can be studied? It can be studied by the synthesis of PCl5. First of all, that is the synthesis of PCl5 can be done. How it can be done? It can be done by taking of phosphorus trichlorides plus here, that is labeled isotope Cl36, here that is Cl2 gas can be taken, and PCl3 Cl2 both can be combined together. Here two labeled isotopes we have taken, and therefore totally here the labeled activity means here radioisotope it will be enters in PCl5, and therefore what happens here, this is the product. Once the product it can be obtained, then it will be hydrolyzed. How this can be hydrolyzed? As here PCl5 plus H2O. Suppose we have taken here labeled isotopes here, that is this will be Cl36 comes in this PCl5, and therefore hydrolysis can be carried out, and therefore it gives as a POCl3. POCl3 means here only 3 Cl atoms which are not labeled, they comes in case of the products, and again here that is the 2 Cl atom which can be labeled, they comes together, means this can be give the information that the labeled two isotopes they will be special different directions, and 3 Cl atoms they have different directions, means here that is 2 Cl atoms they will be seen in case of the structures. What happens, the structure tells that this will be, you can say that is this will be trigonal bipyramidal structures. This gives as concern that is 2 Cl atom which will be labeled, they possess a short distance as compared to the other, and therefore that is 3 Cl atoms which will be taken in case of PCl3, they comes at the 3 corners of this triangle, and therefore totally all the 5 Cl atoms they are not equivalent to the phosphorus atom. This idea can be obtained in case of the structural determination with the help of Cl36 isotopes. Now again you should take next applications, medical application. It is also called as analytical applications, or you can say analytical chemistry applications. It is also called as the isotopic dilution method for determination of volume of bloods. That is, volume of blood can be determined as concerned to the patient. It is very important decision for the doctors to make operations, to supply the blood in case of patient's body. That is, our patient suffering from hemorrhage, and therefore totally what happens here, why patient blood is essential or not essential, this idea can be checked by using of so many types of the isotopes. Here sodium 24, iodine 120, chromium 51, phosphorus 32, all these type of the isotopes they have been used during the determination of volume of blood in case of patient's body. Now what happens in case of patient's body? First of all, the patient suffering hemorrhage or anemia disease, such patients, that is 1 cm³ blood can be taken. That is, first of all 1 cm³ blood of the patient's body can be withdrawn. That is 1 ml blood can be taken. And in case of 1 ml blood, the labeled isotopes, that is Na24 in the form of NaCl, it can be added in case of 1 cm³ blood, and therefore totally the labeled sodium it can be enters in case of 1 cm³ blood, and therefore what happens here, the specific activity of 0.1 cm³ blood can be taken. Here 1 cm³ total blood, among this only the specific activity from the 0.1 cm³ blood can be checked, and this you can say this can be obtained as YS1. The specific activity this will be taken as concerned to YS1. This blood totally it will be taken, and remaining blood you can say 0.9 cm³. It can be re-injected intravenously in the patient's body. That is, patient's body, what happens here, remaining 0.9 cm³ blood can be injected intravenously, and totally sometimes after 10 minutes, 5 minutes, here some time can be given for the circulations of the blood in case of patient's body. After 5 minutes, 10 minutes, the circulation of blood can be occurs, and again from the patient's body 1 cm³ blood can be taken to check the specific activity of the blood after the circulations, and that time what happens here, the specific activity of the blood can be checked. This will be seen as concerned to S2. Here S2 is a specific activity after blood. This will be taken, and totally you should suppose that in the patient's body there will be totally as concerned, that is this equation can be taken. Here y(S1) equal to x plus y into S2. This idea can be taken. This is the, see, after specific activity taken after addition of the, you can say, radioisotopes, and this will be before addition of the you can say radioisotopes, and therefore y(S1) equal to x plus y S2 can be taken, and this y is nothing but this will be taken as concerned to, this is the y means y equal to 0.9 cm cube. This will be very less as compared to x. This x can be taken as concerned to total blood in the patient's body, and therefore y is added blood 0.9 cm cube, and therefore y is very less as compared to x, and therefore what happens here, this equation that is here, y will be cancelled, means this becomes as x S2 can be taken, and we are going to solve as y(S1) equal to x S2, means x equal to y(S1) divided by S2. This cm cube blood can be taken, and therefore when we have taken x equal to this y, this idea can be taken, say S1 and S2, these values can be added and total blood can be obtained in the patient's body. Now this is the third application. Last one application can be taken as concerned to age determinations. Now when we have taken the age determinations, here C14 isotope can be taken. The C14 isotope is nothing but that is addition of the C14. How the C14 can be enters? Totally in the atmosphere, what happens? So many reaction can be occurs. That is nitrogen 714 plus neutron C14 can be obtained. It will be goes in the plants for the photosynthesis process. That is C14 in the form of CO2 gas. And this CO2 gas enters photosynthesis. Food can be prepared. This food can be taken by the human beings, animals. In this way, in the woods, that is the plants, animals, the totally C14 can be enters. When the animals, plants can be died, that time the total activity of the C14 can be measured by taking off, you can say, in the grams. How much gram of the weight, total weight of the woods, total weight of the clothes, they will be obtained by taking off the half-life C14, that is 5730 years. That is here age of the, you can say, historical age of the woods, clothes. This can be determined. It is called as the age determination, C14 dating. Now in this way, the use of the different types of the radioisotopes can be carried out as concerned to the you can say detection purpose. And therefore here topic can be ends as concerned to nuclear chemistry. Today we will stop here. Next lecture, next point.